Okay, peeps, so I've been working on a lighting project and it's just taking forever. Anyway, as promised, I thought I would shoot a video and talk a little bit about UVB intensity, um, and also talk a little bit about these gadgets here. Now, if you're wondering what this is, I will mention this a bit further on in the video. It's basically an orange with a bolt through it, but that's going to come in very useful, so please be patient. Right, so it is the shortest day of the year, the winter solstice in the northern hemisphere of the world. In the southern hemisphere, it is the longest day of the year, so it is the summer solstice down in the southern hemisphere. Okay, so what has that got to do with UVB? What is UVB? So UVB is the invisible wavelength of ultraviolet light, which in the natural world comes from the sun. Okay? And we're going to pretend that this lamp here, which is in test mode, we're going to pretend that that is the sun. Okay? So UVB is the radiance of light which provides the ultraviolet radiation, which is in small doses used to synthesize vitamin D3 in living things, including mammals and reptiles. Okay, now let's go on to this little experiment I did while I was at work the other day. I took some readings. So this wasn't taken today on the shortest day. It was taken a couple of days ago on the 19th. And so I'm up in North Wales, in the UK. It was a very cloudy morning, and at about 9 o'clock there was absolutely zero UV intensity. Okay, now how did I figure that out? I used this device here, which is a solar meter, and these tools are excellent to use to work out the UV intensity in reptile enclosures. Okay, so I've been using this a lot lately while I've been doing my lighting project, and I will shoot a video on that in the future. I was hoping to get it released in time for the winter solstice, because I thought the timing of it would be right, but things have just gotten in the way. Issues have occurred because it is quite a unique setup, but I'll talk about that in the future. But I've been using this a lot to test different lamps, okay, and the UV intensities. So the reason they are so, well, they are kind of costly, but it depends how you look at it, because it is a highly sort of technical device that has been produced, made by experts, and calibrated to produce as accurate as possible measurements of solar UV. Okay, so it's a very handy tool to use, and basically the higher the number showing on the screen, the higher the UV intensity. All right, so I'm just going to put this now under my metal halide lamp, and we can see, so it's a 35 watt metal halide, and we can see that it's producing about at around about 30 centimeters. I can sort of guess that because I've been doing this a lot lately, measuring distances of about 30 centimeters, taking readings. So that's approximate. And we can see that just by placing it there, the UV is about 1.3. Okay. And if I place it, say, about 20, it's 1.7 and so on. Yeah, so we get higher, it goes higher. Okay. So, what has the winter solstice got to do with UV? Well, as seen by the results of my experiment that I did in work the other day, my colleagues thought I was mad. I was just stood in a field taking, with my gadgets, taking readings from the sunlight. Well, or say from the cloud. It was a very overcast day that day. There was a couple of spells of clear sun, but even so, even in the direct sun and clear sun, we can see very, very low readings of UVB, which can kind of relate to the slowing down in metabolisms and behaviors of living species. Plants tend to go dormant. Reptiles tend to hibernate. Mammals are less active. Humans, generally, me included, can get low kind of like fatigue and more sleepy and that sort of thing. And it is all linked to the low dosage of UV, which generates vitamin D3. Okay. And it's through vitamin D3 that enables living things to kind of function properly. Yeah. So it is a very important vitamin. And like we have to supplement our reptiles' food, I struggle sometimes at this time of year so I have to take vitamin D3 tablets to kind of boost my system. Because if I didn't take those tablets, despite eating healthily, I do struggle with the dark, and I've figured out that it's probably due to the lack of vitamin D3 getting into my system through the sunlight. So yeah, if I was off the tablets, then my circadian rhythm and my appetite and everything would just be all over the place, like it has been. So yeah. So I think next year I'm gonna have to plan a holiday in some winter sun. So that's basically why this guy is a very, very useful tool to have in the reptile hobby. Okay. So yeah, so we can see from these readings that we've got low UVI and low illuminance, which is measured through lux, and low power density as well. So this can explain, this orange can explain the whole meaning of life. Okay, so we're imagining that this orange is planet Earth, and the reason I put this bolt in is to represent the North Pole and the South Pole. So we're pretending that this lamp is the sun. Yeah. Now the winter solstice or the summer solstice is the beginning of a new solar year. Okay, which means that the Earth has travelled one full orbit around the sun. Okay, 365 days. Okay, it's done one full orbit. Okay, and I have explained this in a previous video, As it's orbiting, it also tilts at a 23.5 degree angle. So the North Pole is right now tilting away from the sun. If I point it here, it's easier. So it's tilting away from the sun. Yeah. So let's say the northern hemisphere is over here. So it's tilting away from the sun. So that means that there is less radiation from the sunlight hitting that surface area of the northern hemisphere. Yeah. So if we split it in half, you've got the equator in the middle, which kind of pretty much gets the same amount of sunlight every day, because it's in the right smack bang in the center. But the northern hemisphere at this time of year, in the winter, the autumn, the shoulder seasons, that as it tilts, it gets less solar intensity. So then that also means it gets less UVB, because the surface area covering that is further away from the actual sunlight. But the sun doesn't move. The sun doesn't move hardly at all. And the power coming from the sun is exactly the same, more or less. Okay? So the radiation is exactly the same. It's the Earth that is moving. Okay? So as it spins towards the sun, which gives us our daylight, and away from the sun to give nighttime. And in also it sort of moves around like that and tilts. So as it tilts away, northern hemisphere gets summer, southern hemisphere gets winter. At the moment, the southern hemisphere is getting summer. Okay, it's their longest day of the year, so it's their summer solstice. So the South Pole here is tilting towards the sun in the southern hemisphere. Okay, so say Argentina, Brazil, Australia, New Zealand, South Africa, they're all getting summer right now. Whereas in the northern hemisphere, and the UK is probably sort of around about here, we're tilting away from the sun. So the light has got further distance to reach the land surface area and the sea. And also because of the ozone layer and the atmosphere, there's more kind of competition for that sunlight to kind of travel through, if that makes sense. Greenhouse gases, water vapor, atmosphere, all that kind of stuff, okay? Which affects radiation, okay? Which is the power coming from the sun, okay?